With that terminology out of the way, let's talk about printed circuit board pattern libraries. Printed circuit board pattern libraries are created with a pattern editor. The pattern editor lets you create the printed circuit board pattern libraries. Here's an example of one such library. It's just a collection of printed circuit board patterns. These are examples of printed circuit board patterns that I've created. Let's talk about one in general. Here's an example of an integrated circuit pattern. It's the same pattern that will be used for every single 8-pin dual inline package integrated circuit in a project, whether it's an operational amplifier or a comparator or any other 8-pin DIP. The pattern is composed of two parts. It's composed of these pads. These pads represent the copper pads that will be placed on the printed circuit board. No traces are placed in the pattern editor. It's just 4 components. The green here represents the silk screen. The silk screen is not conductive, and the silk screen is the white paint layer that goes on top to identify where the physical outline of the device is. The solder pads may be the same size, or they may be different. Most patterns use a differently shaped solder pad for the first pin just to identify it as special. Each pattern holds 2 other pieces of information. The first are the size of the drills used. If you click a pad, 0.0354 inches. That disappeared pretty fast. If you right-click it and choose Properties, it'll stay up there a little bit longer. There's the drill hole. We'll talk about how to define those shortly. You'll need to zoom in and out. There are zoom buttons up here. You can also use the scroll bar on your mouse. You can move around on your screen here. Take a look at the small layer of grid lines on the back, these grid dots. You can control that with this drop down. You can also make them anything you want. For integrated circuits, you want to make sure that the grid goes in evenly into a 0.1 inch spacing, since the pins on a DIP are at 0.1 inch spacings. This is at 0.05, and sure enough you can see that these pads exist at every other location of the grid, so they're at 0.1 inch spacings. Let's take a look at another. This capacitor. This is the body of the capacitor in silkscreen. That's not conductive, and here are the pads that are conductive. Let's take a look at a different device. Here's a typical jack, screw jack connector. This jack has got a silkscreen outline that's here. It's got 2 pins. The jack itself looks like this. This is a 2-pin jack. It comes in a variety of different size spacings depending upon how much current you want it to carry. This particular one is at a 0.1 inch pin spacing, just like an IC chip would be. These are really useful. You put stripped wires in here, clamp them down here, and they perform a good electrical contact with your printed circuit board. So let's take a look at how that corresponds with our pattern. Green outline corresponds to this green outline, or the horizontal, the flat part anyway. These 2 pads correspond to these 2 pins. We're calling arbitrarily this pin on the left our pin 1 since it gets a different shape. And these 2 things are holes. These are holes because you can't see it here, but there's 2 little plastic protrusions and they fit through these holes for additional strength. You can get information on these holes by clicking them and choosing Properties. There is no copper that's placed around these holes. It's just through holes. And the last thing to realize is you'll notice that the silk screen has little spaces where the holes are drilled. That keeps warnings from appearing, because otherwise you'd have this go partially over the hole and it would obscure the hole, and that would create a warning later on. Can't be printed because it's over a hole.